All right, here's our third video, solving rational equations. We have two more examples to look at, number 5 and number 6 that you see up on the slide. So let's take a look at number 5. So our strategy again is to look at the domain first, think about what values are no good, use the least common denominator to clear out the fractions, and then solve the resulting equation. So in this case, my domain, we always start with all reals and then exclude some values. So all reals except, and then we can look at our denominators to see what values would make them 0. So for this denominator, the value that would make this denominator 0 would be 4. So I'm going to exclude the 4. For this denominator, I need to factor. That is the difference of two squares, x plus 4, x minus 4. So the two values that would make that denominator 0 would be a negative 4 and then a positive 4, right? That makes both of these 0. I already have the positive 4, so negative 4 is also something I need to exclude. And negative 4 also makes this expression 0 as well, so it's no good again. So my domain, all reals except 4 and negative 4. All right, now factoring that binomial here, this denominator helps because that helps me find my least common denominator. My least common denominator is the product of all the different factors. So I have factors of x minus 4 and x plus 4. Even though those factors are repeated, the exponents, the number of times that they occur in each denominator is the same. So my least common multiple will be the product of x plus 4, x minus 4. Now that means I'm multiplying every single term in my equation by x plus 4, x minus 4. So I'm writing it for each term. Really, I need parentheses around that binomial. Here I'm multiplying by x plus 4, x minus 4. So if I'm multiplying every term of my equation, I'm multiplying the entire equation by the same thing. So it holds that principle of equality. Also helps me to simplify my equation as well. So this x minus 4 cancels out with the 1 that we have here. That means we are left with just a 3 times x plus 4 equals. So both of these denominators are going to cancel out. So I'm just left with that 5x plus 4. Here I have a minus sign. I have to be careful with that. The x plus 4's cancel. I have 4 times x minus 4. All right, so now I have a polynomial equation. Let's see if it's degree 1 or higher. So let's distribute. If we have a degree 1 equation or a linear equation, then we will just isolate that variable. But if we have degree 2 or higher, then we'll factor. So I don't see any x squared, so it means I have something linear. I'm going to just simplify the right-hand side here. 5x minus 4x is x, and 4 plus 16 is 20. So I'll get the x's on the left-hand side. 2x plus 12 equals 20. And I'll get the constant on the other side. You just move this up so you can see it. So that gives me 2x equals 8. And then dividing by 2, I have x equals 4. All right, so that seems good. However, we found the domain, and we said that the domain is all reals except for 4 or negative 4. Since this does not agree with the domain, which means it makes one of the expressions undefined, it's the only solution we found. That means there are no solutions. If we had another solution, and if that solution agreed with the domain, then we would keep it, but this was the only solution that we had. So in this case, our solution set is the empty set. Okay, so it's really important that you do check with the domain, or make sure that you have to plug in and make sure that nothing is undefined. If you don't do that, you could find solutions that don't really work. All right, and we have one more example in this series, number 6. Looks a little bit nicer than the ones that we've been doing. Let's take a look at this one here. Again, we only have one denominator, one term in that denominator, which is p. So our domain is pretty straightforward, and so is our LCD. Our domain is all reals except the value that makes this denominator 0, which is 0. So we can get any other solution, which is not 0. Right, so our denominator is our least common denominator, so we are multiplying everything by p. And I'm just going to write it next to every single term, just makes it easier for me to see what's going on. P times p is p squared. Here the p's cancel, we'd have 25. On the other side, 10p. So we have a polynomial equation, degree 2, so we want to get all the terms on the same side, so I'm subtracting 10p. P squared minus 10p plus 25 equals 0. The trinomial, looking for two numbers that multiply to 25 but add to negative 10. Those two numbers are negative 5 and negative 5. So p minus 5 times p minus 5 is 0. Both of these factors are the same, so they'll both give me the same solution. P minus 5 is 0. P minus 5 is 0. They'll both tell me that p is equal to 5. And I'll check that with my domain. It agrees with the domain because they had all reals except 0. This is not 0, so it's good as long as it works here. And you can double check, right, and just kind of make sure. I would have 5 plus 25 over 5. 25 divided by 5 is 5, so 5 plus 5 equals 10, which works. So my solution set is 5.